We are now looking at the Math 2 curriculum for MVP Unit 6, Lesson 5, Transformation Exploration. The first part of this lesson is to observe three different functions, the quadratic, the square root, and the inverse, and kind of compare and contrast their various domains, ranges, intervals of increasing, and different features of the graph. So we're going to begin with the quadratic. Looking at the table and just knowing about our quadratic, we can complete the table for -2 squared being 4, -1 squared being 1, 0 squared being 0, 1 squared being 1, and 2 squared being 4. That can also be seen in the graph, but just knowing the parent function, that is quite easy to think about. If we mark those points on the graph as it's requested, we have 0, 0, -1, 1, and 2, 4, or -2, 4. Then must mirror those points. We also want to look at here our domain and our range. So if you look at our domain, we are going to continue left and right forever. So our domain would be -infinity to +infinity. Our range, we can go down only to 0. So our range will be from 0 to +infinity because we will never stop increasing. Our rate of change is that this is increasing at an increasing rate. And what that means is that as we continue along our graph, we are going to get faster and faster. Those changes are going to be greater and greater. Our intercept here would be, the x-intercept would be 0, 0, and the y-intercept would also be 0, 0. The intervals where the graph is increasing. So when we're talking about intervals of increase and decrease, the words tell us that our graph is going up or down when you think about the words increase and decrease. So you want to look at your x values only. And for my x values on my graph, I am increasing where my x values are positive. So I begin increasing at 0, and the graph does not stop increasing as it goes to infinity. And the same is kind of true for the decreasing, except it is starting to decrease in the negative x values, so at -infinity, and it doesn't stop increasing until it hits 0, where it turns, or decreasing until it's 0, where it turns and begins increasing. This graph has a minimum value of 0, or y equals 0, and the symmetry, we have an axis of symmetry at x equals 0. And our end behavior, what we can say is that as x approaches infinity, our y values are going to approach infinity. And as x approaches -infinity, our y values are also going to approach infinity, just as they did when x approached infinity. What end behavior is telling us is exactly what's happening at the top of the, or at the ends of the graph, not necessarily the top. In this particular case, it is the top because as I go to the left forever, my graph is also going up forever. As I go to the right forever, my graph is still going up forever. So now let's look at the same information with the square root function. To fill in our table, we have the square root of 0 is 0, square root of 1 is 1, and square root of 4 is 2. Let's go plot those points, 0, 0, 1, 1, and 4, 2. Alright, so when we're talking about our domain here, if you notice we can't go to -infinity as before. Here our domain is 0 to infinity. That is also our range. So these graphs do not go into our negatives because of the fact that we are underneath a radical. the rate of change here is that we are increasing at a decreasing rate. And the reason that we're going to say decreasing rate is because as we continue along and we plug in different x values, the y's are going to change at a smaller and smaller rate. So if you think about 9 being the next perfect square, you're at 3, and then 16 and 4. Those y values are still at a rate of 1, but the x values are growing much faster. So if we think about rise over run, 1 over these fractions, these numbers that are getting bigger and bigger, means the fraction's getting smaller. So that's why it's a decreasing rate. The intercepts here are the x is 0, 0, and the y is also 0, 0. The intervals where it's increasing and decreasing, this one does not decrease, so there are none of those. Increasing, it increases over the full domain, so from 0 to infinity. The maximum or min, you could say there's a minimum here at y equals 0. There is no symmetry. And the end behavior, as x approaches infinity, y is going to approach infinity. But in this case, x is not going to approach negative infinity. It's going to approach 0. And when x is going towards 0, y is also going to go towards 0. Alright, and the last one of these was our inverse. So inverse variation, we're going to plug in x. That would give us negative 1/2, negative 1, negative 2, positive 2, positive 1, and positive 1/2. So let's graph those 3 points. Negative, roughly. And we should be able to kind of see what's happening there. Okay, our domain here, as we talked about when we first learned about inverse variation, is that our domain is a joint domain. It is negative infinity to 0 and 0 to infinity. Remember, no brackets around 0 because that is an asymptote that we cannot actually touch. We're just going to approach it. For the range, it's the exact same thing. We're going to be approaching a y value of 0, but we're never actually going to touch it. Describing the rate of change, we'll think through this as the two pieces again, the upper piece and then the lower piece. The upper piece, I'm just going to use arrows here, is decreasing at a decreasing rate. And the lower piece is also decreasing, but it's decreasing at an increasing rate, because as it goes down, it's going to get faster and faster. The intercepts here are that there are none because of those asymptotes. Intervals where there's increasing or decreasing, there's no intervals of increase. And for the intervals of decrease, it's going to decrease over our whole domain. So that would be negative infinity to 0 and 0 to infinity. For maximum or minimum, there is none. There is no true symmetry here. You could say that there is possible symmetry at y equals negative x if you were to reflect your graph onto itself. But typically here we could say none as well. And in behavior, as x is approaching infinity, our y's are trying to get to 0. And as the x values are approaching negative infinity, our y's are still trying to get to 0. Now, the next part of this lesson deals with looking at transformations. So we have 4 different transformations shown, 2 with a quadratic and 2 with a square root function. If you think about the fact that we've already looked at a quadratic, you should just notice that the same shifts are occurring. The only difference is that in the quadratic, the shift with the x is inside a parentheses that's being squared, where the shift with the x on a square root is underneath the radical. Basically, what you're looking at is that grouping symbol of some sort. So the same is true when there's nothing inside, or when there's a shift outside of the x. So like in the last 2 examples, that -2, that is showing a shift down, and that is the same in both functions. So anytime we're looking at our table to decide, anytime we add a number outside of our function, which is adding it to the function, we are going to move up k units. Anytime we subtract it, we're going to move down k units. When we are adding k to the x value of the function, this is going to be a left shift. Again, this is just review from, I guess, unit 3. When we subtract inside of our function, this will be or inside of our x, this will be right k units. Now do keep in mind on both of these, we traditionally use h here, so don't let that k fool you, it's just a variable. And for the last 3, they're dealing with multiplying. Now when we multiply, we've traditionally used an a value here. But whenever we had an a value that was between 0 and 1, basically it was a fraction less than 1. If you recall, this was a vertical compression by a factor of a. When we have a k that is greater than 1, this is going to cause a vertical stretch by a factor of a, or in this case actually k. I'm going to go change that other a to a k. And when we have a negative number, that is going to be a reflection on the x-axis, over or on the x-axis. Okay, now our last 2 examples, there's actually 4, I'm just going to do these 2 with you, are to look at what the transformation actually does to the graph. So we have one inverse and one square root function, and we're just going to plot those new points. So I'm going to take a point and I'm going to perform the transformations that are occurring here. And in number 1, our transformations are up to, and that -4 down in the grouping with the x, think about we do the opposite here, that's going to be right 4 units. So I'm going to take a point like 1, 1, and I'm going to move it up 2 units. So up 2 and then over 4. And I'm going to put its dot in that position. Okay, so I went up 2 and over 4 just by counting and thinking about what that move would be. I can then, even better, think about moving my axis. So I'm going to redraw that really quickly. If I take my y-axis and I move it right 4, that's going to move that axis here. And then if I take the y-axis and I move it up 2, what this allows me to do is to graph this by looking at its proximity to the origin, because now I've just shifted my origin. So now when I'm graphing, I go over 1 up 1, over 2 up a half, and over a half up 2. And I do the same thing on the other side. I go over left 1 down 1, left a half down 2, and left 2 down a half. And what I end up with is a much easier situation of creating my new graph, because I'm shifting my axis versus every single individual point. On the next one, I would do a similar thing. This problem has a reflection, and it has a shift to the left 4, or excuse me, not 4, 5. Alright, so the first thing I might do is shift my y-axis left 5. What that can allow me to do is to move each point to that correct location here. So that would put a point on the new axis, over 1 up 1, then over 4, and up 2. However, I need to reflect those points. So the point on the x-axis is not going to move. The point 1 above is going to go 1 below, and the point 2 above is going to become 2 below. I now have the ability to simply connect those points, and there I have my graph reflected and shifted to the left 5 units. And that concludes this lesson on transformations.